Hello everyone, Math Cat here. Today Tangent is in a little bit of a situation. So, he wants to go to the fish island so he can gather food for his cat family, but he only brought enough fuel for 37 miles. And he doesn't actually know the distance between the boat and the fish island and the fuel to the fish island. He knows that he has enough fuel to get to the boat to the fuel island, and he wants to know if he has enough fuel to get to the fish island and then to the fuel island. The reason why he can't go to the fuel island and then to the fish island and go back home is because there are some strong winds. There are some strong winds that are coming, and he didn't check the weather, so he has to deal with that. But if he goes to the fish fuel island and then goes to the fish island, the winds will already be at the fish island and he will be blown away. So he only has enough time to go to the fish island, escape the winds, go to the fuel island, and then get back home. That is his only path if he wants to get fish. So let's say that there's also a landmark. Here is a star. He uses this star as a landmark. Oh, that's a bad color. He uses that star as a landmark. And once he is at this point, let's call it distance d. Once he's at this point, the star is directly above him. So he can use this star to actually find some angles. So the angle between the boat and the fuel island is b over 2. And then the angle from the boat to the fish island is b over 2 as well. So we can conclude that this angle must be b. And let's label this angle A and angle C. Let's call this side across from the C angle C. Let's do the same for A and B. So, how can we find the distance if we're given some values? Because Tangent knows that he can make it to the fuel island and then go back, that means he does know the distance. And he has measured B as some of the angles by using this star. And apparently he also has a friend who is able to measure the angle from the fish island from the boat or to the boat. So we have 3 known variables. Let's write them out. We know B, angle B, we know distance C, and we know angle C. But first, let's come up with a solution. If we are given this, then we can solve for all the variables. Let's first derive the law of sines. So, given a triangle with an arbitrary height, we can say that the sine of angle C, let's use this angle, sine of angle C must equal opposite over hypotenuse because of SOHCAHTOA. So what is the opposite in the hypotenuse of angle C? Well, we have angle B, side length B, height B, and side length A. So we know that sine of C is equal to opposite B over hypotenuse A. Now let's use another angle. Let's use angle A. So now we know that sine of A must equal opposite over hypotenuse, which is B over C. Now, notice that these two equations, they have a like term, which means that if we isolate B, if we move A to the other side, have sine of C is equal to B, sine of A times C equal to B. We can set these two equations equal to each other. So that must mean that sine A times C is equal to C sine A. And can you see where I'm getting at? We can divide this A and kind of swap them. So then we end up getting sine of C over C is equal to sine of A over A. And we can also assume that sine of B, this is equal to this. So we're given the law of sines, which says the angle of little a over the side length A is equal to any of the other angles over their side lengths. So using that, we can determine sum of our lengths and angles. So, because we are given B, angle B, side length C, and little c, we can, let's first find those values. So we're given those values, so that means let's just say C is equal to 17 miles. Little c is equal to 53 degrees. And these are just random values I'm making up. Little b, or angle B, must be equal to 46 degrees. So, using these values, can you find what are the side lengths of A and B, and see if he has enough gas to make it from the boat to the fish island to the fuel island without running out of gas. Alright, so because we know that the law of sine says that sine of A, or let's you see, sine of C over side length C is equal to sine of B over B. We can find side length B. So let's just plug in the angle C and the side length C. See what we get. Sine of 53 over 17. Let's also move this sine over to the other side. Can we do that? We can also just swap this and this. Sine of B, sine of 46. This is equal to side length B. So, by plugging this into a calculator, you should get the side length 15.31, around that answer, and our units are in miles. Now, because we are given side length B, now can we use that to find side length A? Well, let's set up our law of sines. Sine of A over A must equal, let's use C again. Sine of C, which is, we already know, 53 over 17. How do we find angle A? Well, because we know two of the angles already, we can just find angle A by subtracting the already known angles, right? From 180, and that should give us 81 degrees. So the angle of A is 81 degrees. And then we can plug that into the formula. And also, let's isolate A. Sine of 81 divided by sine of 53 over 17, which is equal to A. If you plug that into a calculator, you should get 21.024 miles. So now we know side lengths B and A. Will tangent have enough gas to travel from to Fish Island to Fuel Island, and then he will be full of fuel and he'll have enough to get back to his family. Let's see. He has 37 miles of gas left. Let's add them up. This should be 36.334 miles. So this trip will cost him 36.334 miles, which is just under 37 miles of gas. So the answer is yes. He can make it to the Fish Island, then to the Fuel Island, and then back to his family. Now, let's cover another application of the law of sines. Let's take a look at another case. Let's say we have a triangle. (42 degrees) and a side length of 32. This is called an angle side angle case because look at the order. Angle, side, angle. Follows this path. Let's try and find the side length across. Let's label the angles first. This is angle A, this is angle B, this is angle C. Now let's label the side lengths. This is big B, this is this is big A, and this is big C. Let's try and find side length B. How do we do that? Well, utilize the law of sines. Sine of B, which is 37, over big side length must be equal to sine of A over side length A, which is 32. So let's first find all the angles. We need to find angle A. We could just do that by subtracting from 180 the rest of the angles, because a triangle is always 180 degrees. So that means the angle little a must be 101. Let's put that in. Now we can just solve for B. Let's move this to the other side of the equation and do the same with here. So we get sine of 37 over sine of 101 degrees over side length 32. That must equal b, which is equal to 19.619 meters, or not meters, just side length. But yeah, you could use this answer to then find the rest of the values of this triangle. You could find C, find anything you'd like. Let's move on to the ambiguous case. Let's take a look at another application. Side angle. Say has a length of 8, length of 7.5, 63. So this is called the side angle application because take a look, side, then it moves on to angle. You could do the other way around too, angle, side, but I'd rather not write that out. Let's move on to the law of sines. So recall that the law of sines, sine A over side length A is equal to sine B over side length B. It's important to note that the inverse is also true. So the side length over sine of A is also equal to side length B over sine of B. So it doesn't really matter what you do. Just make sure you don't do something like A sine of A is equal to sine of A over A, because this is not true. Let's go ahead and get started. So let's label this angle A, angle B, angle C, and this is big A, side length A, C, B. All right, so this case is ambiguous, but let's find out why. So we have sine of A, which is 63, over side length A, which is 7.5, and that is equal to, let's find sine of B. So sine of B, let's find angle B. Side length B is 8. So we can rearrange, move this 8 to the other side. We get this equation. Now, how do we get rid of the sign right here? How do we get rid of that? Well, we can take the inverse of sine, because the inverse of something is just undoing it. So we can take the inverse of both sides of the equation, and that will equal angle B, which is equal to 71.88. Now, this is an ambiguous case. So, because these two angles, we don't know them. These are angles X, angles Y. We don't know these two angles. So, these angles can actually have different values. Like, this angle could be an obtuse angle or an acute angle. This angle could be an obtuse or acute angle. We don't know that. We can't figure that out based off of the law of sines and the given side lengths. So we have to account for both possibilities. can find that by just subtracting 180 from, 71.88, and then we will get 108.12. Now, these two angles basically mean the same thing on the unit circle. So, why is this ambiguous? Well, if we just create a circle, right? This is the unit circle. And it's a pretty badly drawn circle, but let's estimate this degree from using the unit circle. So to create a angle of 71.88, this is around 71.88, and then let's create this angle. It'll be around here. So the angle from here, from the bottom to second quadrant, or the first quadrant, be 108 and 12.12. And then if we take a look here, this is a sine value. Oh. This is a sine value. So if you're familiar with the unit circle, you'll see that these sine values, if you take the sine of both, they equal the same thing. So that's why this case, it's possible for it to be ambiguous. The only time it's not ambiguous is when the given angle is obtuse. Like let's say this 63 right here, let's say it was like 100. Well, you can't have two obtuse angles in a triangle, otherwise it just doesn't work. Like if you add 91 plus 91, that's an impossible triangle. That doesn't exist, because triangles can go only up to 180 degrees. So these are the two possible outcomes for angle B. And then you have to account for both of those situations when finding out the rest of the side lengths. So you'll have two triangles that are possible in this case. And I believe the law of cosines removes that ambiguity. So let's take a look at our final application. Say you have a triangle, angle 30 over side length 7, side length 5. This is called the side angle side case, because side angle side. Now this is impossible to do with the law of sines. You'll need the law of cosines for this. Why? Well, if we label each angle A, B, C, and across big B, big A, big C, let's just write out the law of sines. Let's say sine of little b over big B is equal to, well, big B is known. Let's just write 5. And then we have sine of A over known 7. And then we have sine of known C over unknown C. Notice how we have 3 variables, 3 different things. We can't solve for any one of them because there's not enough information. We need the law of cosines to solve this, and that will be presented in a later video, but that should cover all the laws of the law of sines. Thank you for watching.